Hi everyone, today we're going to take a seat and talk about an elephant that's not in the room anymore but out there in the world, namely the single page applications. In short, I'd like to evaluate their relevance without taking the time to become an expert in their respective implementations. This is a maybe 1 hour long talk about something I did at the Symphony World 2 months ago, for a total of 30 minutes, so this is going to be a slightly slower and a little more detailed version of this conference I gave. This is going to be in English. I could do this in French too, but by the way, nobody really cares about that because you're watching this in English. So yeah, I'll just try to explain everything that's in the slides, and that's the main difference that's going to be between the version I did the Symphony World and this version that you're going to see right now. So if you're not learning anything new, just try to get all the puns on the slides and you'll do the best. So first of all, before we go down the rabbit hole, a couple words about me. My name's William Pinault. When I get asked what I do for a living, I usually answer that I'm a web ninja. I got 15 years of experience in IT, mostly with web development and architectures. I'm currently working in a digital company named Neosoft in a city called Limoges in France, and I'm also a university teacher for several topics. And I also slightly contributed to some open source projects, from PHP CS Fixer to PHP Thig, from Composer to PHP documentation, etc. Sometimes I go online and do some stuff. I'm a spare-time musician, composer, and photographer. I also do some technical conferences on YouTube, and I intend to add more of them like this one. And I'm also playing a lot, like way too much. So you can find me on those social networks here, etc. Also, I pledge I do not have any personal or professional conflict of interest within the topic domains I'll be discussing today. Though it's almost impossible to state that you're truly neutral or independent, this is always a prerequisite, and as you're about to see, is critical in the world of software. Also, disclaimer, I might be using the term SPA for single-page application. So first, let's raise that so-called dilemma, right? Basically, it falls under these questions we all asked ourselves. I know you did. Are single-page applications a progress, like object relational mappers, or are they a private imposter, like Adobe Flash? Or rather, are SPAs the next big thing, or are just another trend? Or if you prefer seeing that from an architecture point of view, should I use them or not? Well, the answer is both. Thank you very much for this talk, and this is over. I hope you guys enjoy the slides, blah, blah, blah. But just kidding. I'll give you more insights. So first of all, let's break down a little history and conceptual definitions, also called the Hitchhiker's Guide to the Boomers, which I'm a part of. Before we start explaining anything regarding SPAs, I'd like to have you all think a little about a simple question. How do new technology concepts emerge within the world of IT? What way do they get advertised, promoted, or how do they become a thing? I won't have time today to dig deep into human psychology and capitalistic economics, but if you look at most of new tech stuff that's been added over the past 2 decades, at least on the web, most of them came from tech giants. And these tech giants basically compete now with universities and public research. They publish white papers influencing the world in a way that suits their infinite appetites. Others follow, as their problems are usually twisted according to these giants' wants. But where does new stuff come from? First, from research, Charles Babbage. Second, university and state development, like the MIT. Third, individuals, like Guido van Rossum or Rasmus van Leerdorf. Fourth, companies developing strategies like Sun Microsystems, Google and stuff. And all that together creates a new stuff which we tell everyone is going to change everything. Or not. I mean, come on. You know many of them. Here's a list I quickly assembled in my head, but you'll complete it quite easily. You see, iframe, Ajax, Cassandra, PyTorch, BERT, TensorFlow, WebM and WebP, WebXR, HTTP2 and SPDY. See, all of these were mostly brought by tech giants. And you know all those technologies, right? Those firms have something in common. They are huge. They don't think small. Google.com handles 6 billion searches per day. Facebook reached 2 billion active users, that's a lot. Microsoft Teams has 150 daily million active users. They do. That's it. They do. You don't. 99.99% projects you will fork and work on will be far below the statistics until they die. And a fraction of this total would potentially share their scale problematics. Again, yours won't. We all like to think it's auspicious to act, think, and behave like giants. A famous French poet, Jean de La Fontaine, wrote a fable 400 years ago named The Frog and the Ox. It's basically a metaphorical poem through which a frog tries to inflate so that it reaches the size of its ox friend until the poor little frog explodes. You get the point. And there's another question. How do we as human people, as digital workers, behave? We actually act like people with a lot of certitudes, skills, and working in a domain with possibly the most Dunning-Kruger effect. The impression, the feeling that we are always better and good at what we do, skillful and competent. We frenzy everything. We break walls first and we think later. That's in the explosive nature of software development. We do stuff because people shout out loud that we should. Don't get me wrong, trying is good, understanding new concepts is good, but acting under pressure or stress doesn't lead you anywhere. Yes, let's talk a little about user experience history. So here's a little biased one when it comes to modern web UX. It's mine, so of course you don't have to follow it and you should be completely disagreeing with it and criticizing it, right? But let's go. First, people didn't really install applications on desktop at the beginning of the 21st century. So they didn't really care about UX, it's just another era. We just had media like CD-ROMs, DVD-ROMs. We just installed software that way. We didn't really care, we just had or had not. We paid license or not for software, and that was all. Then fast forward in time, CSS3 changed a lot of things on the side within modern web interfaces. So this doesn't seem connected, but actually that made browsers add more behavior. And from that, we also have another things on the side coming. The mobile app stores emerged. Pixel perfect mastery through native programming on third-party apps on mobile. As a consequence of all that, we all raised our expectations when it came to UX. Yet, as web evolved too, we realized mobile is connected and still really cannot rely on networks when it's on Wi-Fi, It's still not good. Even with 5G, 6G, the networks are really bad. It's a bad user experience. So in the end, people got used to native applications and expecting the new web ones to be as smooth. Hence, did we all feel that new need for sleek applications? That's what we needed. The need for sleek application. We wanted something to be sleek and perfectly looking, Now more history. A quick history of events that led to the ideas of SPAs. This is a slide I basically simplified for the 30 minutes talk. So at the origins of the web, as described by Tim Berners-Lee in 1991, the word documents is central and explains everything. We use verbs in HTTP, get, post, delete, put, etc., to perform actions on documents, and use a pre-formatted description language that contains hypermedia relations between nodes in response. Documents, at first, were text only. Basically, we requested something to be done, and we get a response telling us that it was made that was made of a request through codified responses, the HTTP codes. Once per document, and a document is a page, and a page has a resource name, locator, identifier, URI, stateless. Then came the need to enrich applications and web UX, because on the side, native applications were becoming better and better. Think about the rise of Swing, GTK, Cocoa, for example, or simply Flash or Silverlight. We started taking off the fully static web experience, so we added iframes. Iframes were the ability to load a sub-document taking place at special XY coordinates. This is when we started thinking of documents parts as components. When we started thinking the experience of browsing in between two page loads or calls. When we added Ajax, which was part of the Internet Explorer API first from Microsoft, with ActiveX components and stuff. With Ajax, we return that asynchronous experience, but we don't necessarily link it to a visual result, which is new. Then came web attractivity. It literally exploded because now large companies, then general public, therefore governments came in and started using our toys. I mean, my first browse page, web page was around 1995. Okay, boomer. Now we only faced Google on the web. Back then we had only Microsoft, hence the historical era of using Internet Explorer, which was an application deployment runtime based on web standards and never a browser intended for end consumers at home. Which is why, at the same time, Microsoft invented lots of new application stuff, while the W3C invented lots of user stuff. When Google came in, and they added more mess. Then Apple and iPhone came in and added even more mess. Those are the times of, for those who remember, the acid test, the HTML quirks mode, the CSS hacks, and the front-end consistency nightmare. I swear if you started after 2015, you're hell of lucky. Then came more market needs. There are 3 moments to me when market needs drove this technology push through. The first one was made by Gmail, with the need to provide a super fluid email application to destroy internet access providers' hegemony with enriched interface in a lightweight web-based client. This had to be real-time, super fast. Google Map, by the way, is also a technology gem. If you have the time to look at the Google talks from the Google Summer Universities about the optimizations they did on Google Maps, this is absolutely brilliant. Then came in YouTube, which came popularity exponentially after Google bought it in 2006. Google was forced to redesign the website completely several times. Picture-in-picture, the continuous scrolling, serendipity, continuous play, designed as a TV killer, all based on web technology. That's pure insanity again, but they did it. And finally, the third great step involved in the rise of SPAs was indubitably Facebook.com. You mean live updates on multiple zone, messages, columns, breaking the Windows stuff, light Windows notifications. Same if you look at the talks leading to the first Facebook components implementations and the release of React. Those conferences are absolutely mesmerizing and brilliant. Like really, it's a really good idea to see what they did there. With all that connected came the need for something new. We could not see these applications as request response for full page loads anymore. They were too expensive. Which is why we started thinking pages not as views and subparts of views anymore, but through new concepts. And hence is the time they came up with the idea of better fluidity, real-time events, and therefore single-page applications. Single-page applications, SPAs. Let's take a basic example with 3 pages, okay? Submitting a form, clicking a link, whatever generates an action, okay? You then identify the limited components inside those pages. Here, view component 1, 2, and 3. Okay, same across the pages 1, 2, 3, right? When designing those pages as a regular web developer, you would recognize those 3 pages here, page URL, page URL, page URL, as views. Those would be 3 views, 1 for each action, and those actions would be usually matched from a controller in an MVC paradigm, using these 3 URLs. Then you would use subparts of views like tweak templates inclusion for elements. For each element you can factorize, and include component 2 on page view 1 and 2, for instance, here, but not on page 3. But what if you start thinking in terms of similarities and started thinking in terms of differences, of pages differences instead? In another way, you would start thinking in terms of controller/view retroactive interactions, and instead start thinking in terms of application states, which is only effective if you would go from one page to another. Here, what changes? Got it? That's the base principle. You change from page 2 to page 3. The state is, do not touch component 1, just remove 2 and add 3. That's the base principles. You then use the browser native API to intercept and prevent default behavior like hypermedia, and you replace it with yours. Here, instead of clicking on a link to go to route 2 on route 2, you load app state for route 2, you calculate the difference, and you update the current view. Which leads us to this generic principle. First, you get the minimal response. Then, the response you got here contains JavaScript that loads and shoves in the contextual components inside the page, maybe using additional HTTP requests, usually through the Fetch API that came through recently, a couple of years ago. All right. So in the end, this lets you all without feeling that on one side you'll be dealing with a shiny interface, and on the other side you let the boring backend architecture and data models to someone else. Which is why, to me, I mean, so many backend developers moving to algorithmic front-end web development, but who literally know nothing about web fundamentals like DNS, HTTP, hosting, servers, etc., which is kind of dangerous. Being a front-end web developer is like being a mobile developer. If the trend falls down, you cannot recycle into something similar, even though you'll probably keep your JS skills, which in turn, by the way, is part of the explanation when there is more and more JS outside the web browsers. To complete the big picture, now we don't send a whole page data from action to action, but we simply send the minimal stuff we need to complete the view instead. So here, in my example, you load nothing between URL 1 to 2. When you do that much of transition, you go from URL 1 to URL 2, you don't need anything. And you don't load anything like just component 3 switching from a fresh application launch of URL 2 to subsequent navigation of URL 3. You see, subsequent navigations are just a differential of the first one. Of course, you're not stopping here. You're also changing what's transferred over the wire too. Since you now import the concepts of models to your front-end data transformers as in any solid architecture. So you're in for data transfer objects. And DTOs here is where JSON won the war. So at least we got rid of SOAP and XSL, which is why, don't forget, we still don't have flying cars and global warming solved at the moment. Just kidding, or not. Here, for instance, the data payload on the render template on the left is exactly twice the size at the right JSON data transfer object counterpart on the right. I counted. This is exactly twice the size. All right? But it's not the only part of history that's worth noting. The history of SPAs is strongly tied to the history of JavaScript and its frameworks. History is a perpetual questioning about facts and a fight against individual views and biases. So here's another version of history I'm giving you. I will just go through that as an improvised version, as this was something I just showed and cut down for the 30 minutes version of this talk. So we'll go from the bottom left. First, around 1995, the early JavaScript is created. If you remember, there's the only link for that is that we used to have Java, where I was just born, to make new stuff, and Java was used for backend applications, and we needed something as cool as Java for the front, but it needed to be a scripted language that could be interpreted on the fly, which is maybe why they also went to mix the name Java and script. It's just not really clear for history. Everyone's got a different answer to that. Then, like I said, the browser war, which was the war between Internet Explorer, not evolving, but Firefox and its ancestors, everything basically what was a browser at this time, Safari too. There was so much confusion and differences into the DOM implementation in browsers mostly and CSS interpretation that we had to go through jQuery to basically manipulate whatever had to be dynamic on the page. jQuery is something that basically saved the internet for like 20 years now. Then HTML5 exploded creativity. It was a standard that was designed to be finished in something like 2025, if I remember, 2025. But then they realized it was so far, they just buckled up and finished everything in like 3 years. So HTML5 was really early and is now a living standard. So then jQuery components didn't unify to basically solve what then was the GAFAM, Google, Amazon, Facebook, Apple, and Microsoft, which is not changed, but at this time it was GAFAM. They had problems of scalability and speed that jQuery couldn't solve. So after this, HTML CSS became a super complex thing, because when we started programming on web development, all the web front-end standards like web HTML, CSS, and JS were considered like, I don't know how to say so, just decoration. Like they were considered nothing, because you would know everything about them in basically a couple of days. Now, the number of selectors and properties has exploded, the JavaScript API has exploded, and even HTML since HTML5 has been way more complicated than it used to be. So now it is a skill. And if you do a service, complex and brandable website today, you have to basically put usually half the people on the front and half the people on the back, even without a front-end framework. So the full stack developers started getting lost because they had so much to learn about whatever, Python, PHP, Java, whatever was used on backend, .NET. It was getting more and more complex, and getting to follow all these ecosystems became way too complicated. So the browser war ended and people wanted simplicity, and in the end, Microsoft lost it. From this Windows-linked hegemony of having 95% browser worldwide to literally the less than 3% today. Open source won it for a moment, but Google's devoured everything with Chrome, and once they had their absolute war machine of advertisement, then convinced everybody that they should go to that. So then we started to have modular approach to stuff. Like I said, we passed the iframe era now. So we started replacing generic HTML, CSS, and JS stuff with the idea we could download code and have repositories of code. And that was the beginning of everything. We started seeing things at modular. So we did not recreate a wheel every time. We just imported things that were taking care of standards way much and in a much efficient way that we do, which is good. And this is why Google started to take over the internet. The business plan really started like at the beginning of the year 24-25. It started developing Google Web Toolkits for as an illustration to that. That is just one of 1,000 projects Google trashed into oblivion. But yeah, one day Google, who was more than 40%, if I remember clearly, of Firefox investing, said, all right, our plan is ready and slick now. We're dropping Firefox financial support. So we're retiring our donations to the Mozilla Foundation. And at the same time, we launched advertisements on every platform because now we control what people think on the internet. We have them on Android, we have them on YouTube, we have them everywhere. So everyone, listen, please migrate to Google Chrome. Guess what people did? They migrated to Google Chrome. When you have the most powerful advertisement sets on the internet that you can't manage to create a need that people didn't have. People didn't need a new browser, they didn't need it at all, but they managed to take everything ahead of time, to create new stuff, to invent new stuff, and to be the only browser to support it. So here's why Google buys YouTube and stuff, and the enhance ad. When I remember clearly watching so many advertisements for Google Chrome in YouTube, which we don't see nowadays anymore. It's too late now. They won the war. They got what they wanted, so it's over. So then Google, as I said, started using Android and Chrome. They started linking both one to another, and Android started to be 75% of mobile operating software worldwide. Mobile won over desktop computers and notebooks. So basically now Google controls everything that's happening on the network and things, and the internet, and globally. Especially the web. But then was a problem. Chrome wanted to go so far ahead of everything that it started to literally eat RAM modules. People didn't increase the number of gigabytes of RAM fast enough for Google, which is why we went from basically in a couple of years, like 5 to 7 years, a browser taking like 500 megabytes of RAM to a browser that would eat 4 gigabytes. And 4 gigabytes is what people had at disposal. So the computer started to crash. So they developed whatever they could. They made different threads from browser tabs and stuff, but it wasn't enough. So they just tried to find a solution to that. So they created their independent rendering engine, their independent HTML synthesis interpretation. They started going further and closer to the standards. And at some point they realized that JavaScript was going to be, like I said, the dynamic thing. People were now expecting more fluid applications. So they found out that the JavaScript engine of Chrome was absolutely killing everything. It was full of memory leaks, stuff. It was really badly implemented. So Google went to work on a new project called V8, and V8 is the source of everything we see today. Everything we know on the web today is what is changing is due to V8. V8 is something, along with turbofan and all the sub-specificities of the engine, really changed how everything worked. It was so brilliantly fast that people started to find a way of having a repository specially dedicated to basically what was under V8. So V8 created Node, not by Google. Node is not a Google creation, but it is an indirect creation in around 2009, I think. And the whole ecosystem was born out of nothing. People needed to have JavaScript components, but they started to use this server as a backend server because there were lots of projects on the internet that didn't need a PHP and MySQL website. They didn't need dynamic backend that much. They just wanted to say, hey, we got a request, we want the article content. And you don't need to have a super strong model, you don't need to have a super strong ecosystem and architecture inside the code to be generic and stuff, have a super generic solution like Drupal and stuff. Bro, we just need to get what is inside the content of this article, which is a text area enriched with RTE, for example, a rich text editor. And on the back end, we just need to log in as an admin and edit that text. That's what we need to do. That's the only thing we need to do. And for that, you don't need 50 megabytes, 200 megabytes of codes and generic stuff and pluggable stuff. We don't need that. We just want to make a simple, super straight website. And all those websites were usually answered with PHP, Python, and Java and stuff. So those languages had very mature models and CMS. So basically, they just recreated simple, super strong CMS and stuff like that. And they realized that going and deploying static pages was more than this. So now, because of that, or thanks to that, we have websites that can answer 1,000 requests per second on the same socket with a single thread server. And that works really well because we just dedicated that to a normal and less overthought system, which is fine because now if you just take JavaScript and you start using a framework like Express or stuff like that, and you start developing your web application by yourself, you realize soon that if you start having complex models and be generic and pluggable and stuff like that, you start creating something that recreates the whole experience of what you have with Django and whatever framework of PHP. You just basically end up being as slow as these languages. You just accept a little more number of connections per second on a node server. But that's the difference. That filled the whole ecosystem, the whole need for a market that was begging for it. So that was really brilliant. And then we had Node Package Manager, and since we needed to have Google Chrome and stuff and Android being ahead of competition, we had to add new stuff. So it's not really innovating, it's just adding new stuff, recomposing, getting the best ideas on the web, listening to them, and implementing them as future standards. You see, Google has a way to determine properly by studies, surveys, and stuff if something is going to be positive or not for people. So they try a lot of things, and they can kill a lot of things too in just a blink. So they try to outpace the JavaScript norms, which is by the European Consumer, I don't remember, ECMA, whatever. They just try to outpace them, but we're just pressurizing them. So like, guys, you're not going fast enough. So they started moving the JavaScript DOM implementation, but also the readability and the vocabulary of the language from JavaScript. So they started using new norms, new ECMA norms, first every 3 years, then every 2 years, then every year. And I think right now every year is not even is not even a sufficient pace to have a new release of ECMA norms for JavaScript. So we also have the browser fetch API at the time, which really changed everything when you needed to fetch something from the backend, as we saw. But it's not going this easily, right? Because even if you simplify what browsers do, your applications are going to be more and more complex, which is, by the way, the thing and the reason why YouTube and Facebook, the most two browse websites after google.com, were becoming slower and slower. But Google did not add, they never added any particular function to google.com. It's pretty the same thing in terms of functionality since the beginning. You just have that Google account on the top and applications, the sign-in button, and everything else is just basically enter a text and we'll find the answers to your text. You have new solutions like news, shopping, books, whatever, but basically it's just the same thing. If you look at what Google did like 20 years ago, it's basically the same. So Google.com doesn't change, but YouTube and Facebook really changed. They added so much stuff. Every month there was a new functionality that was deployed. That was the moment, by the way, Facebook used to have a customer sourced of ideas. They used to have exchange with the community to get ideas. They closed it long ago because now they know more than everyone else what they do. But yeah, so YouTube got slower, and Google had to redesign, like we just said in the last slide. They had to redesign Angular, so YouTube. So they basically created their own JavaScript front-end framework, which gave birth to something we know as AngularJS. Facebook, same, kills your RAM modules, and actually still the same today. So they developed something they call React. It's not the internal version of React we use, but it's an open source version now, we know, because once your technology is mature, if you want to maintain it, you don't want to do it yourself, it's too complicated. You just release it into open source and people work for the beauty of the nation. So they just separated what they used as an internal part from the generic part, and they open sourced the latter. It's the same, by the way, for AOSP and Android. Android is absolutely not open source. It is just only based on AOSP, which is less than 30% of what Android does. The rest is absolutely closed source and you won't have access to it. It's always the same. So that's the same for React or Angular. So then the GAFAM, still the GAFAM or the MEMA today, deployed advocates. They started to have a war machine on coding and the technology ecosystem. So they started to entice people to make conferences, to do whatever they want. Please come to Google I/O Summer. We are just paying you the hotel, the trip, everything. And if you have a problem crossing the boundary, we just hang up the phone and you passing the boundary. There's no problem with that. They have that much power right now. So whatever they needed to do, they just made free conferences, they advertise, they have a YouTube channel now to say with lots of single and beautiful music and happy people, what's the new stuff in Google that you could implement or actually should implement very fast, because that's what it is right now. And the more they do that, the more pace they impose, the more developers worldwide will have to follow what those people tell you to do. So now Chrome reached a 50% market share. It's beyond that now, actually. And thanks to that, because it was new and because JavaScript is a prototype language, it was one of the very only prototype language in the world. It was very free in terms of implementation. It was going over the OOP. JavaScript is beyond OOP. It's just something new. You basically modify the classes and the models on the fly and cascading into objects if you want to. That's really absolutely amazing. So the JS ecosystem exploded, and this went to a trend because there was a whole ecosystem, we're going to talk about that in a moment, that did not exist, and they had to catch up on this ecosystem. They didn't have a DB access, they didn't have an event manager, they didn't have anything like that. So people saw an Eldorado of new libraries, classic and generic libraries that didn't exist in JavaScript. Some of them existed in C, but not in JavaScript. So people went to the Far West, like it was the Far West invasion. There was nothing, desert, and only very little people. So they just had to take all the resources and make themselves a name and try to get to be notified. That's why they need it. And that's why we came to have a lot of new people we never heard about, created lots of brilliant JavaScript things. So yeah. And now that you have it, you have people who work for free. When you work on open source is open. It doesn't mean free. People are paid to do that. And when you work as a person, you just want to make yourself a good GitHub profile or something, you are basically working for free for these large companies. Okay, and with zeal, because you are happy what you do and you're persuaded that you can then have a shiny ass and tell everyone you did that. So you have, like I said, all these business opportunities, and the whole new ecosystem bloomed up and exploded from nothing in JavaScript. So basically, that's the history of JS and frameworks. You might be worried about how to update the browser URL bar while working with SPAs. That was done by adding the history API. States management methods in browser was done in 2011. So you cannot read history, but you can virtualize new item into it. You can push something new and tell the browser that there's a new implementation, or you just should replace the current state, which is why JavaScript, you say go to from action 1 for page state 1 to page state 2. But page state 2, if you reload, is linked to a new route, to a new URL. So you just load the current URL, you put it in the current browser URL, and you say trash the old one, or add the new one. So basically you do that. And you restore the scrolling where the memorized scrolling was when the people change from one page to another. This is, by the way, you know about it. This is, by the way, if you go to a website, especially really hoary-like website, whatever you want to call it, where you just land on a web page and it loads another web page and it just redirects you to another web page. And for 3 pages that were redirected one to another, if you look at your browser history, you got like 1,000 entries, or maybe you know it too, because sometimes on some really early websites, you try to go back, so you natively press your mouse forward button, or click on the back button, or Alt plus left arrow, whatever you want it to do. You just go back to the previous page, and then the browser just keeps you on the same page. It seems like it's reloading. And you look at the history, you keep piling over and over and over and over the same page because it's redirecting to the current action. That's the kind of bugs that you get from using the history API, by the way. I'm pretty sure you know what I'm talking about. In the end, this makes you consider your servers and assets delivery through a backend as a data provider approach. And this followed the logic of backend clusterization, decoupling them not only for backend scalability, but also for front-end balancing. So you had now to solve authentications, sessions, multiple services, etc. So yeah, basically, in a very simplified way, Google gave birth to the new YouTube, which gave birth to AngularJS, and Facebook gave birth to Facebook.com, which gave birth to React.js. I know, it's a little simplified, but you get the idea. And of course, since we are all geniuses who have better ideas than the others, and we start facing a whole, like I said, whole ecosystems full of business opportunities, we witness the blooming explosions of opinionated tools, arrivals of innovation and abstraction, and then came Vue, Svelte, Meteor, Aurelius, Solid, Lit, Stencil, Alpine, Mithril, Häagen-Dazs, Ben & Jerry's, spam. Wait. Did someone edit my slides? Come on, that's not fun. So basically, there was no such thing as multi-page applications. There's no such thing as legacy applications. This is just business forcing words through contemporary architectures to create competition. But since we're not solely refractory to everything and anything, guess what? We're going to try SPAs, and guess what again? They work. Because now, we analyze what SPAs are, let's see what problems they solved and what they're useful for, okay? I won't take much time going through all the advantages, but there are many posts on the web where you can read insightful feedback, and basically, we just explained that in the previous slides, okay? So, at a glance, they use less data on the long run. While you're owning a new page, you wait for minimal updates upon response instead of a full viewport update on the fly. So you can have a cross-page experience like you do on Spotify, YouTube, or Facebook. They alleviate processing server loads by separating the user view for the request calculation. Multiple backends can be paired with multiple frontends. That's also a thing that you don't really think about, but you can use a service-oriented approach and reuse your code to do something different. Locally, a generic web version of your service and mobile application of service, for example. They use also browsers as a runtime, which means they don't have to care about it inside the API changelogs. Okay, so then a couple of things like you are delegating the operating expenses to software clients, which is your server doesn't have to compile templates and stuff like that. The client does. Your mobile is now having less and less battery life because of that. That's what front-end web applications do. And some pretty cool and neat UX improvements, like you remove the flickering to the, the later. There's always some bandwidth latency and the CPU saturation. So when you go to one page from one page to another, you just have those slightly in between things like partial image loads and stuff like that. I know with fiber optics and faster internet access now, we don't see that anymore a lot, but it still exists. And also you just navigate faster between actions. And when there's nothing to change between page A to page B back to page A, it's going to be the same, and there's no chance that you update anything. It's just instant. You don't have to reload it, which is pretty fine, by the way. When it comes to the first point I mentioned as data, as you see here, your typical front-end framework is the cause of this initial roller coaster bump on the left here on this curve. So this would be the average bandwidth. This is purely schematic. I just put the units but not the values. This is just schematic. But when you start the page for the first time, you've never been to a website, or your browser cache is empty or completely out of freshness. It's stale like hell. So you just had to reload everything. So in a multiple applications, you have a little overhead on the first because you have some generic parts you want to use, like images, the top banner, whatever you're going to do. There's an image anywhere, there's an SVG, there's a pure PNG, whatever. You're going to load it and you're going to keep it. But every time you go through a new page, whether you have an empty cache or a full cache, you will have to reload some data on the fly. You will still, on the usage time, you will still have some data to be loaded. But if you use SPI, you won't have to get the surrounding data, the decorative data. It's already in your browser. So usually you just get some little data like JSON or stuff like we saw, and you actually save a little bandwidth on the long end. In terms of reactivity, this would be the same. You would have slower reactivity for the first page load and more on the subsequent page loads. So let's review the problems they bring to. First things first, the web still reads from one-dimensional text sequence to two of them, X and Y in a viewport, and maybe soon 3D in a WebXL standard. There's no such thing as local replacement. You have to anchor stuff and use DOM references explicitly or not. You have to say whatever element with ID you are going to update, internal IDs and stuff. So you're using pointers and stuff. But the web is still not designed as an application you put on each every pixel. You don't have a panel management like you would do on Java with API, with Swing UI, with Spring, whatever you want it to be. We don't have this like the Windows component stuff and Windows. It doesn't work like that. While raising the initial front-end load time, you negate all the efforts made by browsers to optimize loading to meaningful interaction. You basically have to do the same engineering efforts to reduce your time to interaction latency. This is basically why Netflix, for instance, made all its React components load asynchronously in 2017. I suggest you watch Tony Edwards' talk on the topic. It's on YouTube. It's brilliant. Now you know what risk you're taking with one technology, you have twice it at least. Because even if your backend is made of JavaScript too, you'll need to consider language ecosystems, development, human resources and skills, deprecated libraries and the fashion effect, only to mention those. So now, of course, they've been here for a while, so you won't be rewriting components on your own. You'll also need to learn an extra level of abstraction and add frameworks. The frameworks will secure the basics for you, like forms, routing, events, etc. But that's an additional heavy cognitive cost for you and your teams. You see, this is just, by the way, how you would just make a link to a route with React, Vue, and Angular current versions, okay? One more thing that will tickle you a little, you need to keep up with the JS on the front end at least, which means you'll need to find a stable architecture and new libraries, frameworks, and tools to make all your projects work together. Like automation, deployment, transpiling, concatenation, minification, testing, etc. And the thing you had to do with one production chain, you'll now need to do that with two. Additional DevOps, teams harmonization to make sure your teams and workers don't venture into different libraries, ecosystems that others won't master and enter the JS frameworks war. And they will argue a lot on the tools because there is zero consensus in JavaScript apart from V8 and NPM. The repository, not the tool. Even Yarn is a different approach. And one last thing for your developer team, over the last 20 years, JavaScript has gained very little architecture improvement, like modularity, promises, APIs mostly, but it gained a lot of syntax improvements, like arrow functions, spread operators, destructuring, literals, etc. JavaScript is catching up on modern development. It's doing so really fast. So reading JS has become harder than it used to be. Also, for some reason, I found out that people don't really like commenting the code in JavaScript. Maybe that comes from the old habit of not putting comments in straight deployments JavaScript files, so people don't have your comments on the browser. I don't know. So, in addition to that, think of all those third-party scripts like ads, trackers, stats, heat maps, funnel conversion measurements, etc. All that stuff is based on local integration on regular application, purposely evaluating a lot of navigation context, which you'll have to embed as a component and make it aware of your new architecture so that it understands how it works. I recently stumbled upon a free code camp article that mentioned the concept I needed to put name on, the JavaScript fatigue. Since the ecosystems and needs are new, they're explosive, and so are browsers' JavaScript standards and compliance. Therefore, retrocompatibility requires more and more shims and polyfills, and there are still many bugs and unimplemented functions among the most used browsers. You have to admit it, the JS ecosystem is really unstable. Now, developers have to cope up with a new ecosystem where every company wants to dominate with their products, and novelty kills everything they learned up to a few months ago. Because of that, you will now double your software erosion. Remember, this is not the technical debt, right? Technical debt is what you buy as a debt, theoretically enhanced by Walt Cunningham in the 1970s. Software erosion is about software being automatically degraded as time goes by, since if no one takes care of it. So of course, even though the separations of concerns is not going to have you split part of your application logic between your front end and your back end, now some parts of applications will have to be common. And that's a lot of work, because the common and separate parts are very often going to mix deeper than your MVC splitting. And when anything changes, it will very often change on both sides, front end and back end. You'll also need additional control of your callbacks. You're going to need to implement more than a controller or routed application on the front end. SPAs have to explicitly define how all state is generated, refreshed, and discarded by the front end during the whole session. And this cascades into new synchronization problems that are non-existent in a server-rendered world. They could also be vulnerable to cross-site scripting attacks. I know, every website could be, but this just doesn't have really security to that. You can still secure backend endpoints, and most frameworks like Angular or React will escape anything within braces to help. But you might need additional libraries like XSS or DOM Purify, whatever is going to be the next one, to help. So you have to triple check your content security policy and the trusted types. And also, NPM themselves states that around 99 to 95%, 95 to 99% of application code comes from public dependencies. And seeing how unstable the JavaScript ecosystem is, this is actually a real threat. But that's not the end, right? Because security is rarely about the modules you use, especially when they have a high usage and activity. But what about you? You will be tempted very often with a bad design pattern, for instance, that is lazy backend, cherry pick on the front. You see? Which exploits through data bleeding very often. Okay? As mentioned before, you'll be replacing things on the fly, including browser native behavior and parts of the viewport. And not everyone can handle that easily. Scrolling away from the attention zone, manipulating user eye focus, scrolling, losing the scroll part, misleading people to new rules that are not the same. This can lead to a lot of loss of attentions, and the bugs in the browser history can be a trap, like we said, etc. The most difficult part would be sure to make that browsers do native history works, which includes loaders, native history, back-forward cache, if you know about that, new tabs, browser focus, the page titles, scrolling, the bookmarks, etc. For instance, think about the most famous websites you can imagine. Take Instagram, for instance. Here's the photographer account I recently created. I know, shameless promotion, right? If I click on a picture, I get this. On the top right, a carousel cycling through all my account posts. But if I use the back function of my browser, which brings me back to the page on the left here, then I click forwards back again, I get a different view. Both URLs are exactly the same. and HTTP 200 codes. You see, the carousel functionality is gone. The image is not zoomed in anymore, the top comments are not shown, the view statistics link require one more click to work, and this goes against HTTP philosophy. Those requests were HTTP GET and got a HTTP 200 response code, but truly differ. However, the GET method, as you know, is idempotent in HTTP on the server, but on the client? And that's just one example. I mean, have you tried refreshing a page in Jira or Facebook wall? No. Also, using front-end frameworks can become a lying promise, because CPU RAM and using in disk usage increase, due to the fact you're not cowardly deporting calculation on the front end. Hence, the mobile battery usage, which, as you know, is about a third of the reasons why people change their smartphones, which in turn represents between 60 and 80% of their greenhouse gas emissions for about 4% of the mankind total right now, and a high source of close to depletion non-renewable rare materials. Up to a point, multiple tabs can easily lead to memory leaks, and I have some tabs consuming about 4 GB of RAM for Facebook for a single day of use, despite JS engine automatic garbage collection. Something quite tricky you might stumble upon testing and crawling. Using SPS can be a challenge when you're doing automatic LS testing, or simply when presenting it to search engine crawlers. That's not the things you find and solve more easily. Now, there's something that all farts like me we used to think about as progressive enhancements, which is, in short, go to the insertion stuff. You go to the essential stuff and then you add stuff from top to bottom priority. Text first, images later, then audio, then video, then media streaming. Meaningful content first, then decoration, ads, trackers, anything that's injected without being initially requested. HTML markup first, semantics plus contents, then dynamic behavior through JavaScript. While walking this path, we endanger this very valuable principle. And now, most of all, this is the main problem in my teammates face, and this is really dangerous. All the tutorials you'll find online are either Hello World tutorials or simple examples of a funny working app. I've never seen a course made by advanced developers explaining the whole big picture and the concepts of what I just called above the transversal architecture, the mindset I mentioned earlier in this talk, you see, transitioning from one page to another. Thinking your application as a state-based manager, using DOM as a contextual snapshot output. And very often people will be formatted by the first solutions they try. So yeah, all those drawbacks can be dealt with, right? Because, I mean, we killed Thanos, so we should survive this. Now, your development cycles will face new problems, like you're going to examine your critical path, your blocking script path, your packing chunks, your bundle sizes, your library optimization, memory leaks, etc. But you didn't have to before. If you want to tackle those new performance problems, you're going to have to profile them, which means you'll have to use plenty of new tools to track and eliminate your sources of slow. Fortunately, arose the need for browsers and third-party solutions to provide such tracking tools. So you have lots of things like timing API, the mutation observer, you have Google Lighthouse, which is, by the way, one, you should not make Google appear in Chrome to be a slow browser when your website is, which is an opinionated tool too, but it's fine. The APMs are basically evolving to that. And also you have to monitor the physical use of RAM, of battery and disk usage and networks and stuff like that. So allow me to break one last wall. Let's look at this little flow, will you? So as you know, basically there's just two kinds of people, those with loaded guns and those who dig. I mean, those who work in the delegated service companies for others, and those who work for product companies for themselves. In the first case, you just imagine someone selling a SPA-friendly project. This makes some developers specialize. They won't refuse because, you know, employment market is a jungle and has its laws, right? Then this project ends. Those who work only for this are left with, you're left with unpredicted front-end developers who happily escape the full-stack sandwich. So now you have to sell these front-end developers daily rates, or fire them, or ask them to go for a new technology, which they don't want to. The other kind of people here, those who work only for their company, you know, their own product, they might end up being bored because they won't change their projects all day long. So they'll likely try new stuff they heard about because, you know, salary increases, right? So now you persuade everyone that this new internal thing is great and you need to promote your internal evolution to simulate being ahead of market competitions. So you chose, for instance, SPAs and shiny frameworks. So you'll go evangelize on Medium, Twitter, conferences, because you need to keep those developers busy. In both cases, you will now force them and their profiles. What is the stuff they used? And bam, you just explained the abyssal decorrelation between job offers, website technology statistics, TOB index on one side, and the GitHub activity around JavaScript and NPM hype on another side, which is replaced by Python hype anyway now. In short, in the end, at most you get a human resources and contractual flexibility to keep your employees busy, therefore productive. So now you can add blue React, red Angular, or green Vue neons under your commercial offer car, so you look more serious, you know? But to me, SPAs highlight another concern, which is the growing intricate dependency between coding, designing architectures, and setting up production ecosystems. Most students learn programming, not systems administration, or simply put, DevOps. So how about you try proven mechanics first, like cloud optimized services? I know you'll deploy that apps of yours using PostgreSQL, but why didn't you use the cloud provider purpose-built database, right? Does your application use correct caching? Are you sure about that? Do you know about caching? I made a whole talk, by the way, it's on my same YouTube channels about caching. It's quite long, but you like it. Do you really test your HTTP responses? Really? Do you test them? Have you really optimized your assets? I don't know. And mostly, are you certain the code you're slinging into production is rightfully written? That's a good story in long one. Because you know, if you send a cow pie on the moon rocket, you're still ending up shitting on the moon. We face concrete problems with abstract solutions. We have to avoid manipulating DOM because it's super slow, so we created Shadow DOM. We have to avoid events concurrency because it's a nightmare, so we created Flux, Redux, whatever. We got bored with front-end implementation, so guess what? We go back to generating front-ends using backends. But since it was too easy, we also added proprietary layers, like new languages we didn't need. Hello TypeScript. But don't worry, we transpile them. So we mix view outputs with actions or even controllers. So guess what? This is twisted. Now we have static front-ends that use front-end templates. Really? So finally, we go back to static websites. Actually, the Jamstacks and stuff like that is just promoting extra static websites. It's just like, you don't need to be dynamic. You just need to deploy a new website, a new content, instead of having a CMS where people can do this by themselves, because they never do it. Facts. But I hear you. You're asking for this dilemma to be solved. So let's consider this from a solutions architect point of view. As we have seen, when application state is vastly shared between pages, you will probably go for a SPA, which means some topologies have affinities for SPAs, service applications, apps that are not public, embedded, or apps like Ionic, Electron.js, or React Native, apps with high recurring traffic, with prevailing network constraints, etc. But in addition to that, some purposes also have affinities for them. Experiential e-commerce, like online car shops, because you sell a lot of products with a lot of experience around the products, and there are very little products in terms of quantities and numbers. You know, very little SKUs quantity, but lots of things to say around them. Web-based games, for instance, are pretty good things for SPAs. Dashboards, anything that will be massively browsed by user. You see. The longer they stay on the website you're building, the more you can need a single page app. But also anything that requires cross-page seamless experience, like we saw, like media streaming, or as where they came from is social networks. That's a perfect example of that. Or any app which business model implies addictive sessions. Oh, guess what? That's where they come from too. You could also think that any application that is designed to stay open in a tab should be using a SPA. And last but not the least, I think any application with complex user interaction that's either creative, real-time, or collaborative should benefit from SPAs. So as a recap, I tried to assemble my thought process in a chart. Of course, this is meant to be criticized, and I'm likely to update this chart. I'll let you run through this chart in details using the replay and pausing here, if you want to. you should really consider going for SPAs plus backend. So I made an adoption matrix here with what I would call metrics. They're not really rational, all of them, but you see there's a way you should adopt, maybe not adopt, or probably adopt SPAs. And of course, the house number here, there's no middle, there's no 3 and 4, there's no 4 for 0. That's kind of biased. So you should consider going for SPA plus a backend. If you have lots of unique users per day, that's the metrics I put here. It's up to you to put yourself, but that's what I consider a normal website. This is dependent on two things mostly: the world population on one part and the world population that has access to the internet on another part. This is just, the numbers are not going to change upon that. You also should go for single page applications if you have a lot of meaningful page views and calls per sessions. What I mean with that is the wheel calls, whatever is an action from a user that says, I want to know what's behind this button, this action, I want to submit, I want to talk, I want to push, I want to slide, I want to make any gesture, I want to interact with the app. So if you interacted with the app and you have a lot of these, like people are pressing button, clicking on the link, like more than, I would say 50 times, for every time they make a session, it means they're going to stay on your website a lot, okay? You should also go for that if you have a high network saturation, like as we saw, remember the graph a few slides ago, remember the graphs? If you have a high network saturation, you should go for SPAs. Same if you have a huge CDN billing, if you are really build a lot for CDN because people are using fresh refreshes, fresh calls for things, maybe you should go for that. Okay, so you just mitigate a little this. Also, you should go for SPAs if you have a large proportion of fresh, non-cacheable HTTP responses that are not assets. Okay, the assets are not into account, but the assets have nothing to do with SPAs. Even though you will not reload them, which is the difference. If you have an asset and you just don't reload it, even with people with disabled cache on the browser, as long as they use your SPA, they won't reload the asset because you're not changing the DRM. So even if you're using assets, the assets are automatically handled by the browser cache. So it's not about your calls. So if you have non-cacheable HTTP responses, if it's slowing down, the less it is, the more you should go for SPAs, okay? If you have lots of pages that are not calling the backend and completely cacheable, 100% cacheable safely, maybe you should go from one page to another, all right? If you have a high competition among user interfaces, which means you're going to change your interface very often, okay? If you have like a high competition and whatever your website looks like and your mobile application looks like, if it's really critical and it really changes a lot and it's important for you, you should decouple both of them. You see, that's not a rational argument, that's just something that is depending on what you think you're doing. Also, if you have a larger team, because of course, if you asked this person to be alone or one person to be working with one person, it's not going to be cool. But generally speaking, the size of your team is going to be linked to the size of your budget for the projects you use and for the company you handle. So larger it is, the more you're going to actually automatically meet the rest here. So the more you have, the more people you have on the team, the higher expectations on the project and the more it's business centric and generates money and generates activity. So more people use it. So in the end, usually the number of people in your team is linked to the first matrix here and the rest of the page. You see, this is actually a synergetic approach. Also, you need to probably adopt this if you rewrite and redesign and completely redo whatever your front end is more often than the back end. If you do this more than, I say, twice on 2-on-1 ratio, I think it's a good idea to at least think about SPAs. Also, if you change the backend technology of your backend very often, or more often than you expect it to be, this is the opposite actually. If you change the backend technology more often than the front end, maybe there's an advantage to decouple that. So at least you will not have to redo the front end part with a different backend. See, that's quite obvious. And last but not the least, I mentioned in the previous slides, depending on your project typology and visibility. So if you have very competitive search engine optimizations, and if you don't have a large team too, this is not linked necessarily, but if you have a very critical SEO thing, it's going to be even adding more complexity to maintain. So you will probably not go this way. But if you're just using a pure service like intranet, extranet websites that is really used by people, again, an intranet that is not used by anyone is not useful. But if you accumulate lots of people on an intranet, maybe you should go for single page applications. All right. So those were my takes on the adoption metrics you should look at. Also, please remember to be careful. If you listen to your management and commercial layer, they will always answer that the project requirements and claims are on the right column, but while having the left column budget and empirical stats. So yeah, you see, that's the difference. Like they like to think that they're working on big things, like, yeah, we're gonna rock the competition and stuff. Like, can I have access to Google Analytics? No, it's good, it's fine. We're doing fine. No. Most of the websites, the vast majority of the websites in the world belong to the left column. You have to know that, really. The absolute crushing majority of websites and projects in the world belong this. I don't have metrics for that, but if you look at like Alexa's top 100, 10, 100, whatever, 1,000, you will look at the abyssal difference of technology and changes there are. Most of the websites on the internet are belonging to this column and never changed like the 5 last years. You see, that's a metric. That's only when you have activity around your projects. And also, don't mistake the claims and the rest, because people want to be, they don't want to be reproachable. They don't want to have people say, hey, you did not take the appropriate decision when you had to. So yeah, I want to make sure that my website can handle 10,000 visits per day, bro. Or sister, whatever. This is not the same technology. This is not the same project. This is not the same complexity and criticity. If you think you're really going for the right column here, you have to be careful. This is absolutely not the same budget, and this is absolutely not the same team topology, size, the same deployment procedures, the same security and stuff. Everything changes. If you pretend to go to the right, you wish you would go to the right column, but you will not start there. You will start on the left column. All right? So for that, first time, new applications, no expectations, web app with SPA seems to be like a mistake to me. Might be exceptions, it's also more complex than this, but right, you got the idea. One very last point before the end, hold on, how about getting more involved in web architectures? If you want to implement partial UX improvement without using SPAs, you actually have some tools at disposal. You have some tools to create smooth transitions. You have page components to load stuff asynchronously. You have tools to defer complementary loading to create real-time templates or to handle trigger-friendly markup. And guess what? A lot of these tools are integrated, for example, in the Symfony UX initiative if you work with Symfony. So also, don't forget that you can integrate specific components on the fly only without embracing the whole paradigms from frameworks. Just like you could require some Symfony components to build an app, you can require only some React components to build an app. If you need, like, a powerful table sorter with AJAX calls to databases and stuff, you don't need to go for the full framework. You don't need to go with SPAs and different routings and stuff. The components are going to handle that for you. You got lots of things on NPM. Just go for it themselves. You don't have to consider your whole app being done like this. All right. You can go further on structural tools too. You can worry about bandwidth optimization. You can start even reuse HTML over the wire and tune server configuration. It's better than JSON sometimes. You can also replace dynamic by static. You can automate content deployment. Like we said, I just said 20 slides before that. So, most websites are almost never updated. You have a CMS, you have stuff, but you say, hey, who's updating the website? Oh, very often the communications department. What are they doing? They're not working. They don't have the time. They just want something else. So you're like, excuse me, I just browsed the website. We have 12 pages. And I used the Wayback Machine, and I found out that the 12 pages are exactly the same as of today that were used to be 1 year ago. We have zero update. Even on the GDPR or whatever, zero update. Why do we put a CMS there? If you want to need an update once per year, just ask your development team that's working on it. You just have to say, hey, we just want to change the text here. Oh, cool, it's just HTML. They just put the correct HTML. They do snap deployment, and you paid for a website text update, like basically a developer for half a day, and not a full CMS deployment and development and slow websites and caching and stuff. And you didn't generate your own nightmare, all right? So that's something you need to think about. You can start focusing on TCP, DNS, and HTTP flow optimizations with native preventive actions. Taking care of your assets. What's the use of gaining 0.2 seconds time to first byte load if you let all your metadata into unprocessed raw media, like pictures taken from a camera that is just like 4K, 5K, 8K camera? What's the use of loading that on a small screen of 5 centimeters, right? You can go for WebAssembly, please don't. If you really want to go faster, actually I think this might be the next big hype at some point if JS keeps going even slower. You can also check out what HTTP 2 and 3 can do. I mentioned TCP, so now you have also UDP. You can check different application structures for both backend with ESI, the edge side includes, and frontends with progressive web applications. You can also step away from HTTP lifecycle that we just mentioned above and learn about server-side events, WebSockets, Mercure, turbo streams. You can learn about synchronous backend without JavaScript, like in Python, Java, and PHP. Yes, they do have this. For PHP, you can take a look on PHP new fibers. Keep an eye on the upcoming features of browsers. Asynchronous things and lifecycle is going to be evolving now. Or maybe you should start taking better care of the planet and simplify your business needs and start ecologically designing applications. Who knows? Or finally, you can take the best of both worlds and mix them. Okay, this is like madness. Nobody threatens a messenger. You get the point. You could simply configure your server so that certain endpoints are routed by backend dynamic applications, and some others, when necessary, by pure HTML/JS through routing front-end frameworks. Guys, really, I did that on one instance of Nginx with one configuration file. Part of it under a sub-URL was served on a PHP dynamic website, and the rest was served on a Node dynamic website. Cohabitatively. It was great. So this is where I am right now, and my current but never definitive conclusions. Yes, larger companies shape your visions. They have more means, more time, more problems, and they are always a step ahead in competition. No, in short, I'd say 95% of us don't need SPAs actually. But regardless, your human resources and marketing will try to force them. Yet, for very precise reasons, SPAs are effective solutions to very specific problems, but don't think that they're a combination in architectures. Actually, with fiber optics, with 6G on the way, and network connections skyrocketing, there's a possibility. There's just a possibility that they could become obsolete. All right? It's not a take, it's just a possibility. As we saw, and as many talks I've seen conclude, there are usually benefits in everything that appears in tech. So there's always a good reason for technical choices when building apps. And it's within human nature to be in search for approval and support. So it's quite anthropologically and psychologically normal that the people you meet will try and find beacons in your stack so that your project ecosystems validate theirs. So that they can be reassured that the intellectual challenge they faced and solved is perceived as a professional and personal success. Whatever you choose will always be the good choice. It's the one you will success with. You're never a loser. There's nothing such as industrialization or reusability. When a new project comes around, that's a marketing argument trying to justify cost reductions by principles, asking you to work faster and better when they don't have the means to prove you can. Not a technical one. You'll meet plenty of people who have built plenty of projects, and I can assure you that all of them are unique. Do they use a single page application and you don't? Fine. Do you have metrics to compare the success of both solutions? No, you don't. So let it be, and thanks to this talk. I hope you have more clues now. SPAs do really have benefits though, as we saw. They're just not benefits to everyone. Don't let your marketing layer take decisions instead of people with technological knowledge and manipulate solution proposal for pseudo-strategic reasons. Our world is about learning every single day. It's part of our jobs and it's cool. So if you don't try stuff like those SPAs, you might end up being stuck in roles, jobs, and places you will not enjoy. In the end, this is definitely worth a try. Just so as to understand and test the concepts for yourselves at least, which doesn't mean you have to force this concept through any of your projects for CV-driven development. It's just totally fine if you never do. Again, you probably have no reason to, and does not mean you or your structure or your customer or your projects suck. There's about 99% stuff you'll never use among what exists out there in the world, and you'll still fulfill your needs, just like you will solve your single-page application dilemma. In the end, never let the fear of missing out feeling hit you in the face. It's always better when fear misses you out. So thanks again if you've been here after all this time. If you're still awake after all this, I like to thank Fabien Potentier because he gave me the idea to do this talk, and it all started with a challenge hidden behind the fear of my imposter syndrome in the Twitter thread, after all. So it's not the easiest talk I've built so far, so I hope you enjoyed it, and I'll see you later in space, and if you want, keep checking out the videos I'll be adding to this channel. Thank you, and see you later.